Hello everyone, this is Akang Suman here. Now we are going to solve the questions based on the total acceleration. Okay. In the total acceleration questions, it is given that figure shows the slider moving outward on a road with a velocity of 5 meter per second. Okay. The slider which is going to be, this is a slider which is given in the question. This slider is going to be in a sliding motions. Okay. This slider is going to be in a sliding motions outward direction, in the outward directions. Okay, having the velocity 5 meter per second. So I'm going to write here the velocity of the slider that is 5 meter per second. Okay, now when its distance from point O is 2 meter, that is the complete distance from the slider and fixed point, fixed joint, so that is 2 meter. At this instant, the velocity of the slider increases at the rate of 12 meter per second square. Now, velocity of the slider is increasing at the rate of 12 meter per second square. So, I am going to write here the acceleration, that is 12 meter per second square. That is for the slider. Okay. The road has an angular velocity. That is the road angular velocity is given, that is 8 radian per second. I'm just writing what is given in the question. It would be easy to solve the questions when you write down the given things. Okay, and the angular acceleration alpha, that is 24 radian per second square is given. Now you are looking here that omega is in the anti-clockwise direction while the alpha angular acceleration in the clockwise direction. Okay, so when there is angular acceleration in the clockwise direction, there will be the tangential acceleration, okay, in that direction perpendicular to the link. Okay, that is tangential acceleration, which is equal to r alpha. Okay, at this point we have to calculate the absolute acceleration of the slider. Okay, now what is important here? This is tangential acceleration we have calculated. Just we need to calculate it completely, that is r alpha. And what is r in the question? That is 2 meter, and alpha is given, that is 24 radian per second. So that would become 48 meter per second square. Are you getting my point? This is tangential acceleration. Now here you are looking that there is a slider which is in sliding motion on the rotating link. So that means there would be a Coriolis acceleration which has to be generated. So Coriolis acceleration, now we are going to calculate. AC is equal to 2v omega, and we all know that here v is the slider velocity and omega is the rotating, that means the angular velocity of the rotating link. So that is 2 multiply v is given in the question, that is 5, and omega is given also, that is 8, that is 80 meter per second square. We have calculated the Coriolis acceleration as well as tangential acceleration. Now we need to determine the direction of the Coriolis acceleration. I already told you how can we determine the direction of the Coriolis acceleration. First you need to tap the sense of omega, okay, whether it is in clockwise or anti-clockwise. Then we need to rotate the v vector, that means the sliding velocity of the slider, rotate by 90 degree in the same sense of omega. So here there is a omega which is in the anti-clockwise direction, so we need to turn v vector by 90 degree in the same sense of omega, that means like that. So here that is the Coriolis acceleration, you will get the direction. And here we can see that the Coriolis acceleration and the tangential acceleration are opposite to each other. Okay, and the one things that is remaining, that the radial acceleration we have to calculate it, and a radial acceleration formula is r omega square. You can calculate using r omega square, and r here in the question r, that is 2, and what is omega, that is 8 square, and you will get 128 meter per second square. That is the radial acceleration. This is the very complicated questions from the direction point of view as well as the magnitude point of view. That means the numerical point of view, that is important questions, because the number of because there is a chances of error in the answer you will get. So basically you need to focus on the magnitude, okay, and as well as on the direction, because one thing if you miss one thing, if you make one thing wrong, the answer will be wrong, okay, you will get the wrong answer, okay. And this type of questions, if you try first time, you will make a, you have to focus more than, because in the second times you will make a mistake again, you will make a mistake and you will get depressed. So when you deal this type of question first time, your attention would be 100% on that question, okay. Because one thing if you mix it, because there is, if you make a mistake anywhere in the question, you will not be able to capture that mistake, okay. And for the, if you are preparing for gate examinations, we all know that there is a 3 minutes for one question. So basically you have to deal accurately with the questions, okay. Don't be panic, just as a patience, do patience and deal the questions what is given in the questions, and do step by step procedures. Don't be hesitate. If you make a mistake in the questions, you will not be able to find out where you make a mistake at that instant. So I suggest you to do the questions very carefully, and you can take 3 to 4 minutes, doesn't matter, but do the questions correctly, okay. So that is I want to say. Now here radial acceleration we have calculated, and the direction of radial acceleration is toward the center along the radius, and there is acceleration of slider is also given in that direction, outward direction is given, that is 12 meter per second, okay. Now there is a total acceleration that we have to calculate. We have calculated all the accelerations, okay. Now we need to calculate the absolute acceleration of the slider, okay. Now here this is the 12 meter per second in the upward direction, and there is the tangential acceleration, that is 48 meter per second in the downward directions. So when we subtract them, the final acceleration, final acceleration in that direction would be here, and that would be 48 minus 12, that is 36 meter per second square, okay. We have to subtract them, and finally this is the 48 which is greater than 12, so finally acceleration would be in that direction. And when we calculate the radial acceleration, that is the 128 meter per second square, that is 128 meter per second, yes or no. That is r square omega, omega square r, 64 multiplied to, that is 128, okay. Now 128 minus, we have to subtract 12 meter per second, that is, okay. So 128 minus 12 means 1116, and it would be in that direction which is perpendicular to it. So that is 116 meter per second square. Now we can calculate easily the absolute acceleration, and we can calculate it using formula, that is 116 square plus 36 square, and you will get the final answer, and that would be 121.45, 121.45 meter per second square. Don't make any mistake in the calculations, because there are a lot of calculations in the questions, and this is you have to practice this type of questions more than one times, okay. I suggest you, because there is everything we have considered in this question, whether Coriolis acceleration, tangential acceleration, and all the possibilities for the direction of acceleration we have considered in that question. So basically practice this question 2 to 3 times, then you are able to understand how we can deal with the questions regarding accelerations.